Hello children, once again welcome back to my YouTube channel Chemistry Pocket. So myself Sreelatha. So today I am going to explain magnetic moment. Okay, so magnetic moment means what? So magnetic moment is nothing but magnetic field generated by the magnetic field generated by the motion of electron is called as a magnetic moment. So magnetic moment is nothing but it is a magnetic field generated by motion of electron. So what is the motion of electron? Here the electron is continuously moving. So that is called as a motion of an electron. So here electron can have two types of motions. One is an spin motion and another one is an orbital motion. So one is spin motion. So electron can have two types of motions. One is a spin motion. So it is nothing but electron can can rotate on its own axis. Electron can rotate on its own axis. That motion is called as a spin motion. So due to this spin motion, it can have spin magnetic moment. Spin magnetic moment. The formula for the calculation of spin magnetic moment is mu spin equals to square root of n into n plus 2. Square root of n into n plus 2. Here n is nothing but number of unpaired electrons. N is nothing but number of unpaired electrons. Number of unpaired electrons. And the units for this magnetic moment is Bohr magnetons. And the next one is orbital magnetic moment. Orbital motion. Here electron can have two types of motions. One is spin motion and another one is an orbital motion. So orbital motion is nothing but here the electrons are revolving around the nucleus. That motion is called as an orbital motion. So do you remember the solar system? So in our solar system, Earth is also doing rotations and also revolutions. In the same way, in an atom, the electron is also can rotate on its own axis, that is called spin motion, and it can revolve around the nucleus, that is called as an orbital motion. So due to this orbital motion, it can have orbital magnetic moment. Orbital magnetic moment. The formula to calculate the orbital magnetic moment is mu orbital equals to square root of L into L plus 1 h by 2 pi. Square root of L into L plus 1 h by 2 pi. And the units are Bohr magnetons. And here L is nothing but azimuthal quantum number. Azimuthal quantum number. So it is about the magnetic moment. So magnetic moment is nothing but magnetic field generated by the motion of an electron. Here electron can have the two types of motions. One is in spin motion and another one is an orbital motion. Spin motion is nothing but rotating on its own axis, and orbital motion is nothing but electron revolve around the nucleus. And spin motion, due to spin motion, it can have the spin magnetic moment. The formula to calculate spin magnetic moment is mu spin equals to square root of n into n plus 2 Bohr magnetons, and here n is equals to number of unpaired electrons. And due to the orbital motion, so it will have the orbital magnetic moment. And to calculate the formula for orbital magnetic moment is mu orbital is equals to square root of L into L plus 1 h by 2 pi Bohr magnetons. Here L is nothing but azimuthal quantum number. Now let us see how can we calculate the magnetic moment of 3D series elements. Okay, what is the first element in the 3D series? That is scandium. So scandium. So I am calculating the magnetic moment for scandium plus 3. So scandium. So scandium atomic number is 21 and the electronic configuration is 4s2 3d1. 4s2 3d1. And scandium plus 3 is nothing but, so already it lost 3 electrons because of having plus 3. So 4 is 0, 3d 0. So mu spin equals to square root of n is nothing but there is no unpaired electrons in the scandium. So we can take 0, 0 plus 2. That means 0 into 0 plus 2, n into n plus 2. So the mu value, that means magnetic momentum value is 0 for scandium plus 3 ion. Next let us see about the for titanium plus 3. Titanium plus 3. So for titanium plus 3, titanium atomic number is 22 and the electronic configuration, the valence shell electronic configuration is 4s to 3d2. So titanium plus 3, it is nothing but 4s0 3d1. So mu s equals to square root of 1 into 1 plus 2 because only one unpaired electron is there in the titanium plus 3 ion. So 1 into 1 plus 2. It is nothing but square root 3. 2 plus 1 3, 3 ones 3. So square root 3 is equals to 1.73 Bohr magnetons. The titanium plus 3 magnetic moment is 1.73 Bohr magnetons. And the next ion is vanadium plus 2. Vanadium plus 2. So vanadium atomic number is 23 and the electronic configuration is 4s to 3d3. 4s to 3d3. So vanadium plus 2 is nothing but 4s0 3d3. So mu s equals to square root of 3 into 3 plus 2. It is nothing but 3 plus 2 5. 5 to 15 root 15. The value is 2.84. 2.84 and the value is 2.84. So in this way we can calculate the magnetic moment for the remaining elements also. Next let us see about the chromium plus 2. Chromium plus 2. So for chromium, chromium atomic number is 24 and the electronic configuration is 4s1 3d5. 4s1 3d5. In the d orbital it contains 5 unpaired electrons. Okay. So 1, 2, 3, 4, 5. And in the s orbital also it has 1 electron. Okay, in the chromium. So if you take the plus 2 oxygen state of chromium, so it has only 4 unpaired electrons. See here 4s0 and 3d4. 3d4. So already it lost 1 electron from s orbital and 1 electron from the d orbital. So it has only 4 unpaired electrons. 4 unpaired electrons. So mu s equals to square root of 4 into 4 plus 2. It is nothing but, so 4 to 6, 4 plus 2 6, 6 4, 24 root 24 equals 2. It is nothing but 4.89. 4.90. 4.90 is the answer. 4.90. Okay. So it is about the chromium plus 2 magnetic moment. So in the same way we can calculate the remaining elements of magnetic moment also. Okay. So in this way we can calculate the magnetic moment of 3D series elements. 3D series elements. Okay. So you can follow this method when you remember the elements and their atomic numbers and also their electronic configurations. If you remember 3D series elements atomic numbers and also their electronic configuration, you can follow this method. So if you don't remember the atomic numbers and their electronic configuration, let us see. I will tell the trick for the calculation of a magnetic moment. So what is the trick? First write the 3D series elements first. So what are the elements are present in the 3D series? Those are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So here we have to remember the group elements. What are the group elements? From group 3 to 12 elements are present in the 3D series, or not only 3D series, D block elements are present from group 3 to group 12. That means the third vertical column to 12th vertical columns are belongs to the D block elements. So third group, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th and 12th. So this is only enough for the calculation of magnetic moment with this trick. Let us see here. What is the trick? What is the formula we have to use? Means here the formula is group number minus charge equals to x. Group number minus charge equals to x. Here x may comes in the two ways. So x may have the two values. One value is less than or equal to 5 and another value is greater than 5. So if x value is less than or equal to 5 means number of unpaired electrons equals to x. But if the x value is greater than 5 means number of unpaired electrons equals to 10 minus x. Just remember this one only. You can easily calculate the magnetic moment. Group number minus charge equals to x. If x value comes as x less than or equal to 5 means we have to use number of unpaired electrons is equals to x. Next, if the x value is greater than 5 means the number of unpaired electrons is equals to 10 minus x. Now let us see here. Suppose take the okay, Zn plus 2n. For Zn plus 2n. So what is the group number for zinc? So 12. So 12 is the group number. Group number minus what is the charge? 2 equals to 10. So it is greater than 5. The 10 value is greater than 5. So the number of unpaired electrons equals to 10 minus 10. What is x value here? 10 is nothing but it is an x value. So 10 minus 10 is equals to 0. It is nothing but mu s equals to square root of 0 into 0 plus 2. It is nothing but 0. So 0 is nothing but it is colorless and also it is showing diamagnetism. Diamagnetic in nature. Now let us take the another element Cu plus 2. Another element is Cu plus 2. So copper. So what is in copper? Group number 11. So group number is 11. 11 minus charge is 2 equals to 9. So 9 is nothing but it is greater than 5. So that's why the number of unpaired electrons equals to 10 minus 9 equals to 1. So mu s equals to square root of 1 into 1 plus 2 equals to 2 plus 1 3, 3 ones 3. So it is nothing but 3. So the magnetic moment value is 1.73. And because of having one unpaired electron, it is an colored compound and it is showing paramagnetic behavior or paramagnetic in nature. So also take one more element, any ion you can take and check and do the cross checking. Suppose take the titanium plus 3 here. Vanadium plus 2. Vanadium plus 2. So for vanadium, what is the group number for vanadium? It is 5. So 5 minus 2 equals to 3. It is less than 5. Less than 5 is nothing but, so number of unpaired electrons equals to 3. Number of unpaired electrons is equals to 3. So mu s equals to square root of 3 into 3 plus 2 is nothing but root 15. It is nothing but 3.84. Sorry, unpaired electrons, how many? 5 minus 2, 3 is vanadium plus 2. So here for vanadium plus 3, 3.87. Here also 3.87. So both the values are same. So you can follow anyone. So this is the trick to calculate the magnetic moment of D block elements or 3D series elements. So just if you remember the group number, that means so there is it is not tough to remember the group number also. So 10 elements are present in the D block each series. So group 3 to group 12 elements are present in the each series. So write sequentially write first write the elements and note down the group number and do the subtraction of a charge from the group number. We will get the x value. If the x value is less than 5, you can take the number of unpaired electrons as equals to 1, and if it is greater than 1 means you can get the unpaired electrons by doing of an 10 minus x. So substitute that n value in the formula, that is mu s is equal to square root of n into n plus 2. Then you can easily get the magnetic momentum value. So to write this magnetic momentum value, just remember, so it is difficult to find the root 15 value and root 24 value, all those. So for this one, so just remember the 5 values. One more trick is there. So for one unpaired electron, we will get the value as 1.73. For 2 unpaired electrons means we can get the value as 2.84, and for 3 unpaired electrons means 3.87, and 4 unpaired electrons means 4.90, and 5 unpaired electrons is nothing but 5.92. So remember these values only. So if number of, first observe the number of values. If number of values are number of unpaired electrons. So based on the number of unpaired electrons, we can easily write the values 1.73, 2.84, 3.87, 4.90 and 5.92. Okay, so this is the magnetic momentum concept. Okay students, so this is about the magnetic momentum of 3D series elements. So I hope you understood. So please like, share and subscribe my YouTube channel Chemistry Pocket. Thank you.